Question number 5 says, in the diagram, the graph with equation y equals to fx is shown with a solid line, which is this one. And the graph with equation y equals to gx is shown with broken lines, which is this one. We have to describe the sequence of 3 transformations which transform the graph of y equals to fx to the graph of y equals to gx. So basically there have been 3 translations on this original equation which translates into this new equation. For the first translation, if we look at the graph carefully, we can see that in the x-axis, this part of the graph covers 2 blocks, this part covers 1 block, and this part covers 1 block. Whereas in the new graph, this part covers 1 block, this part covers 1 block, and this left part covers 2 blocks. So if you observe them carefully, it goes from 2, 1, 1 to 1, 1, 2. So basically, it has been flipped vertically, and in transformations, it's reflection in the y-axis. So we get a new graph which looks something like this. It's a reflection in the y-axis. So this is what our new graph looks like. And we can write it down as a reflection in y-axis. And the equation for this will be y equals to f of minus x. For the second translation, we can observe that in the x direction, the values remain the same. Whereas in the y direction, over here, we have 4 units, and over here, we have 2 units. And on the other side, we have 2 units over here, and we have 1 unit over here. So basically, what's happening is that it's a stretch in the y direction with a factor of 2. So basically, any coordinate that we have, let's say 1 or 2, it gets translated, it gets stretched by a factor of 2 and it becomes 2, where 2 gets multiplied by 2, which becomes 4. So every coordinate that we have, the y coordinate will be multiplied by 2. So over here we have 0, 3. Over here it's minus 1, 1, minus 2, 1, and lastly we have minus 4, 2. So we can write it on the right side. And all the y coordinates will be multiplied by 2. This will become 0, 6, minus 1, 2, minus 2, 2, and minus 4, 4. We can plot the new coordinates. So 0, 6 will be here, minus 1, 2 will be here, minus 2, 2, and minus 4, 4. This will give us our new graph. We are close to our final graph, and we can write this as a stretch in y direction by a factor of 2, and the equation will be y equals to the original equation that we got after the first translation, and it will be multiplied by a factor of 2. For our last translation, we can see that the equation that we got, we just have to translate it to the left by 1 unit, and it's the easiest translation. So we can write it as translation of 1 unit to the left, and we'll write this as -1, 0 in the matrix form, and the equation that we'll get will be y equals to 2 f into minus x plus 1, as this shows that the graph has moved to the left by 1 unit. For the last part of the question, we need to find an expression for g of x in the form e of f into px plus c, where a, b and c are integers. So we can copy the equation that we wrote in the first part as reference. We know that the original equation was y equals to f of x. After the first translation, we got y equals to f of minus x. Then after the second translation, we got y equals to 2 of f into minus x. And after the third translation, we got y equals to 2f into minus x plus 1. We can calculate this, and we'll get y equals to 2f into minus x minus 1, which is our g of x. And if we compare it with the form that was given in the question, we have a of f into px plus c. So we get a equals to 2, b equals to minus 1, and c is also equals to minus 1. So a equals to 2, b equals to minus 1, and c is also equals to minus 1.